Mechanical and wear properties of aluminum 6061 silicon carbide graphite hybrid metal matrix composites. In recent times, the use of aluminum-based HMC has increased widely in aerospace and automotive applications. In the current studies, we are looking at fabrication of aluminum 6061 HMCs with silicon carbide and graphite as reinforcement, and the liquid metallurgy method was adopted for the fabrication of the HMM. So the optical studies revealed that the presence of aluminum, magnesium, silicon in aluminum 6061 matrix alloy and presence of silicon carbide and graphite within MCs. As the percentage of silicon carbide and graphite is going to increase within the matrix, the density is going to increase and the hardness values also are going to increase. This can be rightly attributed to the presence of silicon carbide at 98%. It will be observed a higher weight, higher hardness and density values. As the percentage of reinforcement is going to increase, the porosity also increased. The porosity increased also due to the presence of the gas entrapment and the shrinkage during the solidification and hydrogen gas evolution. The dislocation density and increase in the yield strength was also observed due to the presence of higher weight percentage of silicon carbide and graphite, and due to the presence of the thermal imbalance that is caused in the matrix alloy during the solidification process. As the percentage of reinforcement is going to increase, there's a decrease in the percentage elongation and increase in the ultimate tensile strength, indicating the increase in the hardness of the composites, which can be clearly observed with respect to a quasi-cleavage kind of failure observed during the tensile studies. As the applied load increases, the wear rate is going to increase, specific wear rate is going to increase, and as with the increase in the percentage of silicon and graphite, there was a observed that specific wear rate decreased. So the wear rate of HMCs has been influenced by the applied load, which is the most important factor in regulating the wear and the wear height loss. The wear height loss of AL6061 matrix and HMCs increased with the load increase in the load, and further the degree of grooves that has been formed on the wear track of matrix alloys and composites containing lower volume fractions of silicon carbide reinforcement is extremely large at higher loads, and the matrix alloys and the composites containing lower volume fractions of silicon carbide reinforcement undergo significant permanent deformations resulting in a serious wear. The volume of grooving in composites increased as silicon carbide and graphite material increased. This is also evident from the SN plot. Conclusions: the stress casting technique was utilized for the fabrication of aluminum 6061 SiC graphite HMMCs, and 9 weight% of weight up to 9 weight percentage of silicon carbide was used, and the graphite was kept constant at 1 weight percentage. The density and hardness increased with the percentage of weight percentage of silicon carbide increased, and the presence of these particles within the alloy is evident through the micrographs and EDX. As the percentage of silicon carbide and graphite increased within the composites, we can evidently see that the tensile properties also increased. This is due to the superior hardness and tensile strength values of the silicon carbide and graphite. The dry wear test results indicate that aluminum 6061 silicon carbide graphite HMCs offered higher wear resistance than that of matrix alloys. Increased loads and sliding distances in the wear test resulted in higher wear loss. Additionally, from the overall investigations and findings, it may be concluded that aluminum 6061 9 weight percentage of silicon carbide 1 weight% graphite composites exhibit significantly improved physical, mechanical, and tribological properties in comparison with other composites that was considered in the present study. Thank you.